Hey everyone, and welcome. Today, we are going to crack the code on complex numbers. Now, I know they can look kind of intimidating at first, but trust me, they're built on just a few simple rules. Let's dive in and break it all down.
So how would you solve this? Take a good look at it. You've got multiplication up top and division on the bottom. It looks like a beast, right? Well, stick with me, because by the end of this, you're going to have every single tool you need to solve this thing, no sweat. I promise.
Okay, so here's our game plan. We're going to start with the easy wins, adding and subtracting. Then we'll get into the one rule you absolutely have to know for multiplication. After that, I'll show you division's secret weapon. And then we're coming right back here to conquer that final challenge. Sound good? Let's do it.
All right, first up, let's get some easy wins on the board with adding and subtracting. Seriously, if you've done any basic algebra, you've pretty much already got this down. The big secret? Just pretend I is X. That's it. So let's grab a problem straight from our worksheet here. Yeah, let's do question 2. We're just going to add two complex numbers and write the answer in that standard X plus IY form.
Okay, so what do? It's all about combining like terms, just like in algebra. You take the real parts, the 3 and the 2, and add them up. That's 5. Then you take the imaginary parts, the 2i and the 4i, and you add those up. That gives you 6i. Slap them together and you've got your answer, 5 plus 6i. See? Told you it was easy.
All right, you've got addition down. Let's level up to multiplication. Now this is where things get really interesting because we're about to introduce the single most important, game-changing rule in the entire world of complex numbers. It's just one tiny twist, but it changes, well, everything. This is it, the golden rule. Write this down, tattoo it on your brain. I squared equals -1. So whenever you see an I with a little 2 next to it, it stops being imaginary and, poof, it turns into the real number, -1. This one little fact is the key that unlocks everything else.
Okay, let's see this thing in action. We'll jump back to our problem sheet and look at this multiplication one. We've got 3 plus 2i times 4 minus 3i. Let's get our hands dirty.
So you know the drill here, right? We just use the FOIL method. First, outer, inner, last. That gives us 12 minus 9i plus 8i and minus 6i squared. Now stop. See that I squared at the end? That's our magic trick. It becomes -1. So -6 times -1 is +6. Now it's easy. We just combine our real numbers, 12 and 6, which is 18, and our imaginary numbers, -9i plus 8i, which is just -i. And there's our answer, 18 minus I. See how that one rule completely changed the game?
Okay, we've nailed addition and multiplication. But what about division? Dividing by a complex number? That just feels weird. You're not really supposed to leave an I in the denominator of a fraction. So how do we fix it? Well, we need a secret weapon. It's called the complex conjugate.
And you know what? It sounds fancy, but it's ridiculously simple. To get the conjugate of a complex number, all you do is flip the sign of the imaginary part. That's it. If it's a plus, you make it a minus. If it's a minus, you make it a plus. Simple as that.
So you see z on one side, and its conjugate, which we often write with a little bar over it, on the other. They're basically twins, except for that sign right in the middle. And that tiny little flip, that's the whole key to making these fractions work.
All right, let's put our new secret weapon to the test. Back to the sheet we go. Look at this one. We need to simplify 1 divided by 2 plus 3i. This is the perfect job for the conjugate. Okay, here's the trick. We take the conjugate of the bottom, which is 2 minus 3i, and we multiply both the top and the bottom by it. Now watch the magic happen in the denominator. When we multiply 2 plus 3i by 2 minus 3i, those middle I terms, they just cancel each other out. We're left with 4 minus 9i squared. And what's I squared? It's -1. So it becomes 4 plus 9, which is 13, a beautiful, clean, real number. That's what the conjugate does. It vaporizes the I from the denominator every single time.
Okay, you've got it. You can add, you've mastered the I squared rule for multiplying, and you know the secret of the conjugate for division. You have all the skills, it's time. Let's go back to that final boss from the beginning.
Here it is again, the final challenge. But this time, it doesn't look so scary, does it? We've got this. Let's take it down step by step. First things first, let's handle that numerator. We multiply it out using FOIL, and don't forget our I squared equals -1 rule. A little bit of simplifying, and boom, the whole top just becomes 8 minus I. Much better. So now we've just got 8 minus I divided by 1 plus I. And what do? We use the conjugate. Multiply top and bottom by 1 minus I. We grind through the multiplication, replace that I squared with -1 again, and look at that. The denominator just becomes a nice clean 2. We split it up into the proper form, and there it is. Our final answer, 7/2 minus 9/2I. We did it. Not so bad, right?
And there you have it. You just tackled a pretty complex problem by breaking it down into simple steps. So let's do a super quick recap of the essential tools you now have in your toolkit. Basically, it all comes down to 3 things. 1, for adding and subtracting, just treat I like X and combine your like terms. Easy. 2, for multiplication, use FOIL. But always remember the golden rule, I squared equals -1. And 3, for division, your secret weapon is the complex conjugate. It's your best friend for getting that I out of the denominator. That's the whole playbook. And look, this stuff isn't just for math class. These exact same tools, they're used all the time by electrical engineers working with AC circuits, physicists diving into quantum mechanics, and people doing signal processing. It's fundamental stuff. So the real question isn't about the worksheet anymore. It's, now that you have these tools, what other really complex problems out there are you ready to unlock?